in less than 28G with hydrogen and shit. Have you considered that? I think I stumped him.
I think he's still thinking about what the hell you just said.
All I did was quantify the mainstream
Definitely
assertion.
for that.
Isn't that just wild how that works when you do that?
Plus, I don't think like we had to talk about gravity last time. We're not refuting. No one's disagreeing that things fall. We only disagree as to why things fall, as Stone went over with mass attracting mass fantasy. I think we went over that quite clearly last time, right? Do you remember kinematics and dynamics?
And electrostatics and a whole bunch of that, yeah.
Let's see. Let's see. I think I have something on this too.
So Evan, are you like consulting AI right now about my question, or do you have any thoughts
No,
on the
no.
subject?
I don't really prefer to engage your methods. I mean, so I
My
pointed out to them.
methods?
What are
You
I
don't
pointed out
like
to
my
them.
methods?
Yeah, the interruption. So I pointed out to them that it doesn't make sense to straw man how because we don't assume that gas laws are broken. We assume there's a container. So why are flat earthers straw manning when they know that globe earthers don't think that there's no container? We think gravity contains. That was my point. And then you asked me questions, and
All right.
based on your past, you ask a lot of questions, but
I
don't
asked you
provide a lot
about
of answers.
gravity because you mentioned gravity, and we talking about the sun because you mentioned the sun. So all I asked you is if you ever quantified the gravity that exists allegedly on the surface of the sun. What kind of methods of mine do you have a problem with here? I'm missing that.
That's kind of what
I think you're just
Your
talking
past
way over
behavior.
his head.
No,
So,
he
Evan,
wasn't.
I'll try and break it down simply
See this
for
kind of
you.
stuff. So I mean, I guess you'll get your answer or you
I'm
won't
trying
someday,
to make
Stone.
it
We have lots of
simple
people
for
here
you,
apparently.
Evan, so you can understand what he just told you, because you obviously missed everything he told you.
He asked me questions.
Right? Basically, he took your assertion that gravity is the container. He didn't even say it's not.
Wrong. That wasn't my assertion
No.
just now. My assertion
Yeah,
was
you
that it
you
doesn't make
just
sense to
said that
straw
we
man.
straw man.
Yes,
You
that's my
said we
assertion.
straw man your position and say that there's no container when gravity is your container. And so he ran with what you said and then talked about the strength of your container. That's what the 28 G's is about.
So,
So yes,
ho- ho-
that's how I followed. I agree. That's what he did.
so check
And
this
then he
out.
asked me questions about technicalities. But
No,
originally, still, my point isn't that gravity is real or not. Me and Stone have kind of talked about it before. My point was that it doesn't make sense because globe earthers don't think there's no containment. So whoever's talking
yeah,
about
we
the
know you
third law of
think
gas,
gravity is your container.
right? So why are you talking about something
Yeah,
before the
no,
argument?
I
we
was
got a
talking
All
about
problem.
gravity on the sun.
So,
Wow, man.
so no one straw manned your position, okay, Evan? But check this out. It's a little clip here. It's going to be Evan, theoretical physicist Davis Gross, who won the 2004 Nobel Prize in Physics. Turns out he doesn't know what gravity is. They can describe the effect in what we see and can measure the speed of things fall, but we don't know the cause, which seems to be the problem that we can't get an answer on. And we've been looking for this for over 400 years. Here you go.
What is gravity? Stunned silence. Any order? No, just jump in, please.
I wish we really knew. So, I mean, we can certainly, it's easy enough to describe properties of gravity. It's easy enough to describe theories of gravity. We've had two marvelous theories. But what is, for somebody like me, raises the question marks and not the answers that we already know. So, in a deep sense, we don't think we know the answer to that. But if you look,
I mean, these are theoretical physicists that won Nobel Peace Prize can't tell you what gravity is. Are you sure you want to go ahead and hang your hat on something like that?
Dude, that's awesome. You have that queued up. I
yeah,
think that's amazing.
it's theoretics, man. It's the best current thing. That's all it is.
So it's an imagination that can't be proven.
hasn't been proven, but it is an
nor
imagination guess.
nor isolated.
Yeah, you can't prove
Well,
gravity in any
maybe he
way
likes since he
situation
likes
for what you want to claim it does.
yeah. Since you like
Can you claim it being violated?
theoretical things, I have a theory that double rainbows are caused by unicorn farts, and you know how I know it's true? It's because you can see fucking double rainbows. They're
There you
there.
go.
So obviously, my
Ooh.
theory that unicorn farts cause double rainbows is
It's still,
valid.
And Ken's
And you
math
can't prove
proves
it
it.
wrong.
and he's got.
No, your math, Kevin. That's what's proving it.
So
You
you
know what I mean?
said, can I disprove this or whatever? Is that what was your question again there, Evan? Can I disprove it?
For his double rainbows, you do the same
no wait,
thing.
no wait, no, not
I'm
for that,
answering. I
not for
promise I'm
that.
answering.
You
I'm answering what you said, Nick. I promise.
you said
Trust me.
something
Trust me.
about what laws were being
Yeah, trust
what
me.
laws were being broken.
Yeah. So I'm answering you by also answering him. His rainbow thing. If you could prove it wasn't caused by rainbow farts, you'd have what he just prescribed to
So
have, which I forget his wording.
so you're asking.
But if you couldn't prove it, you couldn't disprove it. So rainbow farts could be if you never get to the end of a rainbow.
No, those were unicorn farts, though.
Yeah, it was.
You gotta be sure about that.
Yeah, unicorn farts at the end of a rainbow. So, and my point about laws was, if you can disprove it, then you prove the opposite.
All right. Well,
but
first and foremost,
if you can't prove the opposite
well,
or
hold
the
on a minute.
positive, then
I
you
get
just
you.
have
I get
theory.
you, man. I get you. You made your. So anyway, first and foremost, gravity is a theory. Therefore, it is not a law. And what debunks it are actual gas laws that require pressure to be in a container, as Alan stated earlier, and also volume needing boundaries. P and V, buddy. P and V. You need a container.
You got a hand up.
Do we have a hand up? What's up there, Water?
Oh, I just had a question for Evan about mechanical systems that don't require maintenance. Do you have examples of that, Evan?
No, there's no eternal machine, no eternal anything.
Right. So what is the maintenance schedule of the 12,000 or so satellites flying above you?
I have no idea. Until their solar panels degrade and don't function anymore, some other electric failure.
They run out of thrust.
How are they going to degrade?
Why do they degrade?
Just pure.
Why do we have satellites up there for like 50, 60 years?
Gaskets,
Gaskets,
I don't know what
seals.
the solar panel black parts are made of, Graph. I have no idea what they're made of, but I don't think they. Yeah, I don't know what would degrade them. Just UV, I guess, after a while.
How about NASA's claim that in every 24-hour span, we're talking about a couple of metric tons of detritus coming from space hitting us at 10 to 40,000 miles per hour. Little teeny projectiles that all allegedly burn up in orbit and stuff. But of course, they're still going this speed and they're still fully intact when they're up, 400 or 500, 600 miles above Earth, allegedly, right? Because there's no atmosphere to slow things down up there. So they'd be going full speed, and there's like every day metric tons of these little teeny rocks and shit all hitting the Earth at all angles, at all speeds. But none of it seems to be taking out the satellites ever. We talk to a guy on Discord constantly by the name of Josh. He is like on the team to put these satellites up there allegedly. And one of them, or actually out of the 60s, whatever happened, he's done. Some of them have been up there for 4, 5, 6 years now. And he has no explanation at all for how they're still working, if we are to believe anything that NASA claims at all.
Of course.
Shoot, man. We got the Voyager, man.
Yeah.
Launched in 1972. It's 15 billion miles away and still sends us signals, and it takes about 23 3/4 hours to get
How does
there.
that make sense?
Beautiful pictures.
So I would say the way you put it, it doesn't make sense.
Thank you, Evan.
But
thank you for understanding that you cannot. Thank you for understanding that you cannot have mechanical systems that don't require maintenance. Thank you.
Of course.
I'm being honest. It's a hard thing to
don't
admit.
sense any sarcasm.
No, it's.
I hope you don't sense
no,
it in
no.
me
I'm
either.
not
People
trying to be
admit
rude.
that
It's just that
I'm not.
this is like a step towards understanding, like a big step.
Yeah. So about the, I don't know what element or what material you said is reportedly raining from space and getting burnt up in the atmosphere, but
Dust and rock.
dust and rock. So yeah,
Yeah,
that's a
you know,
lot
all the
hitting the
stuff they
surface.
claim is up there,
Yeah.
silicon, carbon, all those cool things.
Yeah.
They keep claiming all that stuff is falling on us. Not that we ever see any of it in our own yards or anything,
And
but
12,000 satellites in geosynchronicity,
So
according to them.
it sounds like that's a lot of weight hitting the Earth, but it doesn't make me instinctively think, oh, that would have destroyed some of the satellites. Like
well,
to
no,
you, that seems like it would, but to
it's
me, it
not about
doesn't.
the weight, but try a numerical calculation. Out of 2 metric tons,
Yeah, that's fine.
if nothing of that volume was bigger than a golf ball, and frankly, most of it, you know, closer to a grain of sand, right? That's a lot of projectiles in
Yeah.
24 hours, right? Now,
2 metric tons
yeah, and now
over
extrapolate
the
that.
whole surface of the Earth. No, see, I'm not going to say that's a lot. Over
But
the
you
size
see,
of the Earth, I would
extrapolate
say a
that for
lot.
years, day by day by day by day by day. You know what I mean? That's
Yeah,
not a
and then it
lottery anymore.
starts.
That's a likelihood.
Yeah, then I'm saying that
Okay.
seems like a lot, but I'm still not I'm not seeing it for sure. Like I'm still just reckoning in my head, so it's not too moving.
Probably gonna happen. So
No, that's cool.
So
I got time. You know, think about it a lot, Evan. I hope you truly do, because you're going to find out how little of what I'm pointing out here actually does add up.
Yeah.
To be honest, I didn't check your Rowdy post just because I didn't want to make an account. Just to be honest, I did not read that stuff that I said I would read.
Didn't check my what post?
The other social media, I think it's the one that Rumble. I didn't check your reference there that you.
Well, you
It was
don't
for
need to
the
have an account
spacecraft
to check
mechanics.
Rumble. All you have to do is check my bio and click the Rumble tag and enter FE amount of stone if it's not already automatically part of the key. Like, no, you don't need to have an account at Rumble to watch Rumble. I don't know what planet you're on, guy.
So Evan,
Well, then I'll check it.
Oh, go ahead, Karen.
Video.
Well, he was just confessing that he didn't do any of the stuff that you said he would do last time. I think that's what it was.
That's okay. They never, so Evan, part of
Oh, not never. There was one guy who did.
Oh,
remember Jonathan?
Oh, he followed up.
Yeah, he even posted a comment on one of my videos on Moon Part 2, I think. And we talked about vector analysis and frame of reference and stuff on a comment or two. And I recommend that he talk to Eric on Discord on Eighth Cause, because they have a lot more in common. They're both globies. They're both, truly inspired by mathematics and are into speaking on those terms strictly. And Eric would be glad to talk to him. So yeah, points to Jonathan, 0 to Evan.
Makes sense. So, Evan, are you
1 to Evan for being honest and admitting it? Sorry.
No, Evan, do you believe in the moon landing?
Who's that?
Yeah,
Direct?
if I'm in heaven and God's asking me, he says you got to guess right. I say we landed 69.
Right. Okay. So.
Wow.
Oh, wow.
That's wild.
That's a pretty strong answer, dude.
That's pretty wild. So
do you
ever watch the video of the departure sequence?
It's been at least 10 years.
Right.
If I have.
So just so you know, from a cinematography perspective, that's called a tilt, rack, and stack. It's one of the hardest shots to make. And to claim that humans somehow in 1969 could remotely control something 250,000 miles away and perform a perfect tilt, rack, and stack is almost crazy. Like you're at the point where you're just lying to yourself. How they could remotely control a camera with cinematography that would make someone in today's world drool from 270,000 miles away. Did they even have 18.8 modems back then? Like,
quick question out of ignorance.
No,
was
go
the
ahead.
Landing
we're talking about the
at all,
departure,
or was it completely?
We're talking about
departure?
who,
was it
who
completely
filmed,
manual?
We're talking about the supposed remote controlled camera that NASA operated from 270,000 miles away to film the departure of the Apollo spacecraft from the moon. Now you understand what I'm talking about.
Yeah, just the panning of the camera.
Yes.
What number is that again? Apollo 11? Yeah.
I mean, if they're
270,000
saying it's all
miles. They
remote
didn't even have
controlled,
we didn't have modem-based telecommunications back then, right? It wasn't even a modem, right? 270,000 miles away, and they're performing cinematography that would make like today's cinematographers drool robotically. Like, and this is what you're telling me you believe, right? So take yourself a little more seriously. There's still a lot of Globers that will admit that the moon landing was fake. Like, you can still sort of like tell yourself that you live on a ball, but we never made it to the moon. And there's lots of Globers that come up with valiant reasons why it was fake because it had to be kind of bullshit. But please be honest with yourself first that we never made it to any moon. And then eventually you'll level up and understand that the moon is not a 3D object that can be landed on. And then it'll be interesting to you to understand why you've never seen the other side, or why it doesn't rotate, or why it produces its own light, why the clouds near the moon are lit up but nothing else around it is lit up. That can't be sunlight. Like, it's very obvious when you start understanding things why you're being lied to. So thank you
I got a
for
question about
acknowledging
that
something
camera.
Okay, go ahead, Vanby. Sorry.
The purported camera that filmed the lunar module leaving. What was that film? And was it purported to be film? And how did they get the information back?
I have no clue. You can go ask Grok and they'll come up with some bullshit. The same way that they can't explain the amount of air that they had, right? Because there's no way they had enough air. Well, they had lunar support. They've literally invented a story for every single. They had whatever lunar support packs that could somehow generate oxygen out. Like, come on, like, it's retarded. It's retarded.
Oh, we went into cameras this week.
Ken knows.
They were talking about one of the camera that was mounted on the lunar rover. They said that it was a broadcast camera, and it could only broadcast back to the lunar lander, but the lunar lander had 20 watts that it could broadcast, and they had 65-meter receivers that were I don't know, super cooled or some shit like that. So that they could filter the image, and it'd come out, really great, and from 250,000 miles away. But they're saying that they had broadcast cameras,
Yep.
and apparently they did have broadcast cameras that might have been about that size. But what I'm trying to figure out is if the one on the lunar rover could only transmit to the lunar lander, which wasn't that far from it. How the hell
No.
was this one transmitting when it took off? What was it transmitting to?
Exactly.
Dude, I had to ask Rock because I never thought about this. And honestly, it says, listen, obviously it was captured by the remotely controlled TV camera mounted on the lunar roaming vehicle, and it was a live video sent back to Earth in real time via the rover's high gain antenna, which relayed the signal to the command module in lunar orbit and then to the ground stations on Earth. No worries. No physical film was involved in this shot. It's analog video footage. Black and white camera was converted, broadcast live, and recorded at mission control. The rover and its camera were intentionally left behind after the astronauts departed. Thus, there's no film recovery needed. Well, that's wrapped up in a nice, neat bow. What do you guys think?
Picture as well on the rover there with the camera and the dish that there's also no tracking system for where Earth's going during this time. How are you sending the signal in the right direction? You know what I mean?
I think they only came out with this because we came out with what happened to Larry the camera guy. Like, the guy you left on the moon who took the camera shot that, was impossible to send it back. The poor guy, the poor soul who sacrificed his life so we could have that shot. They were like, well, here's a whole new technology we didn't tell you that we used, like, duh.
We didn't just leave somebody on the moon, man. But, I was all like, even this equipment that they want to say, I mean, this is what it's dealing with. First off, the moon I said, what is the temperature on the moon? And it said the moon has no atmosphere, so temperatures may vary drastically depending on whether the location is direct sunlight or in a shadow. And there's no average global temperatures like Earth, so it's either or situation here. Uh, Daytime direct sunlight, we're getting up to 127 degrees Celsius or 260 degrees Fahrenheit. This is the maximum recorded at the lunar equator around the moon, because they did a survey of the moon and stuff and went all the way around it. Got to the equator and stuff apparently. In the nighttime, it gets down to 173 degrees Celsius or minus 280 degrees Fahrenheit, or colder during the long lunar night. About 14 Earth days, temperatures plummet. Extreme cold and permanently shadowed craters, especially near the poles, as low as 238 degrees Celsius or negative 396 degrees Fahrenheit, or even 250 degrees Celsius in some deep craters where sunlight never reaches, measured by NASA Lunar Renaissance Orbiter.
Those are
Reconnaissance.
where
Incroyable.
those craters where they never get any sunlight. That's where they find all their lunar ice. We got water on the moon,
Got
boys.
water in space.
I like how the figures change over the years. It's sort of like the estimate of the distance to the sun has for the last 150 years, 300 years, or however you want to pretend we're actually keeping track. Like I got an article here from 2013 where the hot side of the moon is a little over 120 C and the cold side is about minus 170 C. And those were nowhere near the figures you just quoted. I love it. It's so much fun. We should plot that over time and see how they look.
So
It's getting colder and
it's getting
hotter.
colder and hotter in space, huh? I guess that's what
Yeah.
happens when it expands at 4 times the speed of light. I mean, you got to expect something like that, right?
Well, I got a question. They keep talking about the thermosphere and the temperature range. I mean, you can fucking Google the temperature range of the thermosphere, and it's these outrageous numbers. And everybody says, well, actually, there's no heat because there's no particles. And I'm thinking, but if you put something there like the ISS, um, that's made of particles, don't they heat up? And they're like, no, I don't get how nothing heats up because there's no particles to heat it up. It doesn't make sense to me.
Well, the whole transfer in a vacuum thing is only for sunlight, apparently.
Yeah,
Well, I
you
mean,
need, in order to have
it,
ambient temperature, you need air
Well, there's no
and a lot
atmosphere on
of
the
it.
moon, buddy.
No, I know. That's why there's no heat
I'm not
transfer.
talking about ambient temperature of the air. I'm assuming there's no air there. There's
Yeah, there's
nothing
no
to
air.
heat up. All right. You got temperatures though. You can Google those
Yeah, that's
for the
the that's the
thermosphere.
that's the energies of the
Right.
particles.
So if you put the ISS there, do you have particles there?
Yes, you have particles.
Okay. So then those particles have to heat up.
No, because they're not the air particles that the temperature is being measured at.
Where does the temperature come from? How do
You
you measure temperature
Absorption.
if there's
temp
nothing there to measure?
temp okay,
Absorption.
what you measure is the energies of the particles. That's basically what temperature is. It's the energy of particles, but what you feel is the large amount of particles that we have down here hitting each other and you,
Okay. So let's go with the energy of the particles. What's giving those particles that energy?
the sun.
The sun. So if I put the ISS there, what's going to give it its energy?
The sun.
The sun. So the particles or the lack of particles that is up there has nothing to do with transferring heat to the ISS and has everything to do with the sun transferring heat to the ISS.
Which is why the ISS is a giant mirror that is made of silver, essentially.
Oh, he's back.
Oh, silver doesn't heat. I gotcha.
No, it's reflective. It bounces the light, as much light as it can, away. It limits the heating that is imparted by the sunlight.
So all I need to do in the summertime is coat myself in silver, and I won't get hot.
Or wear entirely white.
Or be in a vacuum.
If you wear entirely white, the heat that you will feel won't be coming from the sun's light. It will be coming from the air around you. You remove the air around you, and then all that energy comes from the sun's light, and then you reflect the sun's light away, and you're limiting the exposure to high energy.
You think it's a coincidence they're silver plated, dude? Why do you think they got that mirror finish on them?
That's why people who suntan have mirrors, so that they don't burn themselves.
I suntan and I don't use any mirrors.
I think they do it actually to tan their face more. Like, both reasons.
Yeah, bounce the light and the energy to get whatever.
What's got silver on it?
What is the argument right now?
The
What are you guys
International
talking about?
Space Station, the outside is a very reflective coating.
Allegedly.
Well, I just asked the ISS, or asked Grok, is the ISS coated in silver? And it says no.
I didn't say it was coated in silver. I said it was silver-like. It
Kinda
looks like silver.
Kind of like aluminum.
I mean, aluminum will do the same.
I mean, that's what it is. It's made out of aluminum. You know how
Yeah,
thick
it's made of aluminum.
Foil.
Is there an issue with it being made out of aluminum?
Well, yeah.
Airplanes are made out of aluminum.
A little bit.
Out of all the structural materials, aluminum has by far the lowest melting point. How about that?
And check out, it's freezing out there. All right, it's cold as hell, bro.
How's that a problem? The melting point.
Okay?
It's also one of the softest metals that can damage most easily. It's a non-structural material.
That's why
It's a non-structural material, but we use it for construction, cars, and airplanes.
But we don't put it in a vacuum where it's negative 455 degrees.
Seems like, sounds like.
Number from.
So what are the walls made of that can withstand 15 psi on the inside, nearly 0 on the outside for such a gigantic area?
Aluminum.
Yeah?
Airplanes are made of.
Really?
Yeah, Stone. Do you
Do
realize?
you think it's maybe a 1/4 inch thick?
Dude, this is gonna crush you out. This is gonna be stupid right here. Because I just asked it. I said, "How thick are the walls of the ISS?" And you know what it told me? Typical thickness, 2.5 millimeters to 4.8 millimeters, about 0.01 to 0.019 inches.
So 1/5 of an inch almost. Nowhere near a 1/4 of an inch thick, right? And you're saying it's aluminum?
And on the other side of this, 0.19 inches is death.
Well,
yeah. Do you know how thin an aluminum can is?
Have you ever put an aluminum can inside your freezer?
Do you know why it blows up? Because you're freezing the liquid inside of it, and the can can't hold that because it's so thin.
Now think about that part.
Yeah.
There's a difference between air and solid liquid.
You do realize, you probably don't, but air is invisible water.
Air is air, and it is a lot less compressed.
How do you think condensation happens?
It's our ether.
Condensation is the water vapor in the air. Air itself is not water.
When I said the air is invisible water, you would then now agree with me.
The air has water vapor.
Dude, you're not making your case any stronger, man.
Now, what I was going to say, an aluminum can is, let's see, 0.100 millimeters thick, and that's holding 30 pounds per square inch.
Yeah, how many square inches in total?
Does it
Maybe
matter?
less
It's a
than 20?
lot.
Let's put that can in their freezer and
No,
replicate
hold on,
space.
Brad. Hold on, Brad. Like, seriously, less than 20 square inches? So that's the total force that it's holding back there with its
What
0.10.
it's holding back. What it's holding back is the pressure, the 14.7 pounds per square inch outside,
Mm-hmm.
plus the liquid on the inside pushing out.
Well,
and
that is the
gas on
pressure.
inside pushing
That
out.
is all the pressure inside it. I'm talking about the total area of the can in terms of square inches because it's PSI, what we're talking about here. That's the SI part. I'm quantifying for you here. You with me?
Yeah, my point is
Are you
that
with
aluminum
me?
can hold back
Yeah,
pressure.
call it 20 square inches, dude.
Okay, so it's probably a fair bit less than 20 square inches, but we're just going to call it, say, 20 for sake of an order of magnitude stab in the dark. You're okay with that figure?
You should call it 10.
Not 20. Fuck it. 20 square inches. Now, how many square inches is the total area, all the walls of the ISS? Not counting the hatches even. Screw that. Just the walls. You know what I mean? How many square inches is that?
The size of a football field.
Tens of thousands of
mean-
square inches? Yeah, times 15 psi with a gradient of 15 psi across the thickness.
Yeah.
You think aluminum's going to hold that?
Yeah, it's about
That
the same amount of
that
that's the
many square
amount.
inches.
Yes, Stone.
Aluminium will, guys. Yeah, certainly. Covering quite easily.
More.
Stone.
That's
This
what
is
Stone
why
has.
we make airplanes out of aluminum, because it can hold back a large amount of pressure.
No,
It's light.
not
Yes.
really, because that's only a difference of maybe 5 psi, and an airplane is nowhere near the size of the ISS, buddy. Like, where are you going? And in fact, there's a lot of
You realize
glass
the
and other structural
747 is
reinforcement, and
almost as long as the ISS.
747 is a cabin within the fuselage itself that's pressurized. You know what I mean? There's layers to it. The
Yeah,
ISS
how do you
does
think
not
the
possess.
ISS is? Yes, it does.
No.
The ISS has layers.
Yes, it certainly does.
It has the
Okay.
outside walls, and then it has a computer compartment, and then it has the walls of that computer compartment, and then the living areas.
Dude, I told you the walls are 0.019 inches thick.
The skin, not the wall.
Dude,
Where are you going with the total square footage, Stone, when we're talking about
dudes,
PSI?
dudes. I said, how thick are the walls of the ISS? Typical thickness, about 0.1 to 0.19 inches.
To answer your question, Evan, I'm quantifying the outward
aluminum
pressure in total.
can-
To what end when we're talking about per square
That's
inch?
you're
Boom. To that
yeah,
end.
you're quantifying. So
That's
not
This is why it's what's a waste of time. Is that is? I mean, it's
that's
just
not how
on,
pounds per square inch
boom,
works.
and
It's the
laughing.
same pressure all the way through.
That's
Yeah,
correct.
so that's why when I asked him that, he says, "Boom."
Yeah.
Like you can't multiply the amount of square inches by the pounds per square inch and say, see, aluminum can't do this. Pounds per square inch, it's the same all the
No,
way through.
He
That's
thinks
not
you
how
can.
pounds per square
That's
inch
right.
That counts to him.
That's just not how that maths out.
Have you seen the oil tanker rail cars that have been imploded?
Yeah, because you've made those a vacuum, and then
Right.
there's 14.7 pounds per square inch pushing in.
Right. And that shit is like a quarter inch thick or so because it has to hold tens of thousands of gallons. It's a lot of mass. You know, trains, they do things heavy anyways. Welders just like it that way. You know what I mean? Really thick thing. And somehow they managed to implode it with the same gradient.
You know why that
The
is.
same
You're being
reciprocal gradient,
dishonest.
I should say. Yet,
You know why that is.
you don't think that's going to happen with something 50, 60 times the size of that car with
That's
far
positive
less
pressure on the
holding it
interior,
together.
bro. So
because it's pushing in.
it's positive pressure, Stone. Are you dead ass, bro? Are you dead
It's
ass?
pushing
Is this how you
inward.
talk?
Yes, I know.
Is this how you think?
I said
Aluminum?
imploded. When I talked about the rail car, that was the verb I used. It imploded it, right? I understand the difference. I used the word reciprocal. Are you picking up on what I'm saying? The point is,
Stone.
look, no, it's absolutely geometrically ridiculous to consider.
Stone, the thing about aluminum is it can expand outward. The moment it compresses inward, it's going to collapse because it's made to expand outward, which is why it works so great with airplanes. Because airplanes expand and contract, expand, contract. That's called a flight cycle. Airplanes literally expand and contract, and that can lead to metal fatigue. That is something that they do, and they're designed to do that so that the pressure will stay inside.
Yeah, but we're not talking about anywhere near the same gradient. Okay? When you're going up to 30, 40,000 feet. You're dropping to maybe 5 psi, not 0. It's an entirely different tolerance. And it's an entirely different scale of size of the vehicle
It's also
we're
an
talking
entirely
about.
different kind of aluminum.
Oh, it's magic aluminum, is it?
You realize that
You think it's pure aluminum? In either?
There's like aluminum can aluminum, there's aircraft aluminum, and there's spacecraft aluminum.
There's spacecraft aluminum.
They're different.
Duh.
They're different tensile strengths. They're
Feel free to post the date on that. I'd like to see that. That'd be fun, just
Stone guy's
for
bad
kicks. You know what I mean?
Stone.
Hold on, Stone. You didn't know there was different aluminums for different aircraft?
Oh, look, it's
You gotta be shitting me.
coffee. Oh, look, it's coffee. No, really, F6, post the docs on that. I'd like to see the figures. That would just be fun to entertain. Hey, Coffee, you've been talking a lot of shit about me recently.
Post the docs about there being different kinds of
You know what's crazy, Stone? I feel exactly the same
You have
way.
no idea how happy
Look at
Stone
that.
is
The
that this
feeling
dude
is
got here,
mutual,
bro.
buddy. How you doing?
Bro,
was
did you just ask me to post the proof that there's different kinds of aluminum?
I mean, I'm sure happy. I'll tell you
Aircraft
that,
aluminum
to be
is.
honest.
Let him change to talk about this. He was real excited when this guy came, so I understand.
Yeah, no, I'm gonna let him, but I'm still confused.
And yeah, F6, that's what exactly I asked for because it's what you Globies do all the time. Where's your source? Where's your this? Where's your fucking that? You know what I mean? I'm saying, hey, you're quoting it, your claim, you back it up with substance.
You're asking someone with an airplane as their name and profile picture for the source on what
Oh,
aircraft.
you got an airplane?
Whoa, I didn't see that. Hold on a second. Let me look
Shit.
again. Let me look
He's
real
only
close. That is a
17.
legit airplane. Oh,
That's an
It's totally
airplane.
an airplane, man. You got
And it's
it,
like
man. You got
in
it.
the air. Oh, wow, dude. You getting the point?
Have you gotten the point that it's kind of common knowledge in aviation that the aluminum can aluminum isn't used to construct aircraft?
Then why did you use it as one of your examples?
Because it's a different thickness and tensile strength holding back more
And what
pressure.
happens when you put your aluminum can inside of a freezer?
The liquid inside freezes and
Boom!
the can expands
and guess
outward.
what? There's liquid inside of the ISS. It would also freeze.
Why would it?
It's
insulated.
Dude,
why would they?
You don't have to talk back
inside
and
a
say
freezer?
stuff like that, Shane. You can ignore them, Shane, and wait for someone to say something smart. It works better.
Nick, you realize that in space,
better to
water
guide the
boils,
conversation
it doesn't
towards smart
freeze.
conversation.
You realize
entertain horse
it's
shit.
negative 455 degrees out there, right?
Water will boil at that.
And tell me why it's not boiling either.
Because
Why are they
inside
allowed to
the
just hang
space
out
station.
there and just eat cakes that don't float up in the air and drink water out of cups and stuff? Tell me all this stuff, man. Jesus Christ, man! You got no water boiling, you got nothing freezing. Everybody's just having a vacation
Is
up
the
there
water
in the ISS.
is the water inside or outside the space
Dude,
station?
this is the same thing as your aluminum can inside of a freezer, bro.
Is it inside or
Dude,
outside?
everything is inside, otherwise they would die. It doesn't
Okay,
change the fact
so
that the
you read
thickness
the
of that
inside
is
of the space station has
0.01
this.
to 0.019 inches thick, man.
The
What's
the
keeping that cold
International
from
Space
going
Station
inside of
has
that
this thing
aluminum
called
can?
insulation.
What's keeping that? Where's the insulation at 0.019 inches?
That's not the skin. Isn't the insulation?
Dude,
the
I asked,
same
it's
way
the
that the
walls,
skin of an
bro.
aircraft.
The walls.
No, and it gave you the figures for the skin. Do you know how thick aircraft skin is?
Dude,
it's a lot thinner than that.
Dude, is your aircraft in space?
Hold
It's
on, wait. Did you
pretty
check his
damn
profile
close.
picture?
Is your
Is it?
aircraft? No,
Hold
it's
on.
not pretty
Is
damn
it?
close.
No, it looks blue. Hold on. I don't think he has expertise to speak on airplanes in space. He can only speak as an expert of airplanes in actual atmosphere, according to his profile picture right now.
That's true. That is blue air behind the aircraft. That's true.
So, what, like, do you know why it's called aircraft aluminum? Because it's aluminum that's made for aircraft. Then
Put up
spacecraft
your
aluminum.
figures. Put them up or
Spacecraft
shut up.
aluminum.
All done with it. Thanks, man.
Coffee. I didn't know you were beefing with Stone. Stone, I didn't know that you were beefing with Coffee. Do you guys hate each other now? Or is this in good sport? You guys having a disagreement? Like
Well, you
Scully
telling
and
me everywhere I go, people like, yo, Stone Coffee's fucking on, what's it, on the clubhouse just talking about you right now. Would you like to go debate him? Oh man, he's telling us all about you're wrong about this and you're wrong about that, and boy, you should talk to him. It's like, well, fairly done doing that, man. We established that that wasn't such a fruitful thing. So, like, what is the deal, Coffee?
I think that's just Coffee. I think that he tells everyone that we're wrong about everything. If I'm not mistaken.
Well, Coffee has a different theory for everything, so you're always going to be wrong.
Yeah, it's not really with any information that Stone has given. I actually think Stone is pretty knowledgeable, right? I just think the last time we engaged, right, it was pretty disingenuous. Yeah, it led me to the conclusion that you're full of shit.
Dog,
And
that's not going to change, dude. It's not going to change.
it's nothing
You just not
personal.
talk to Stone. Thanks for having me,
It's
Nick, though.
just
You're cool, buddy.
yeah, it's just a critique of engagement. That's it.
Critique of engagement.
So you're not going to offer any substance, just ad hom. Is that all you got?
What did he say that you can refute?
What were you guys even disagreeing on?
Well, no, I overheard Stone, right? My name was mentioned. Stone said that I was uncomprehensive, that I didn't understand the data, and that I failed to stillman him. Which is disingenuous to me because I never attempted to stillman
during that session.
Terrible defense. Ooh.
During that session, you will recall, I hope, that it was not just myself who were quite evidentially convicting you of simply not possessing the requisite level of understanding of the topic. And we started to doubt your intelligence based on your failure to even comprehend that we were pointing that out and how we were taking what you were saying and producing that conclusion.
So what did I say, Stone? Enlighten me, please.
It was about the trigonometry itself and what you didn't understand about this little celestial theodolite, rather, during one of Alan and Shane's innumerable presentations. I can't believe how many times these guys have put this information out, and you guys some of you guys just don't get it. It's amazing. And I'm not going to go into specifics again, like I was even saying that night, that it's not my battle. It's one that I haven't taken anywhere sufficient time to study if I were to pick up the sword on it. But what was clear, that we were talking about in terms of experimentation, even, that when we look at the process, the method for the celestial theodolite, you were not really showing any coherent grasp on which were the independent variables, which were the dependent variables of the experiment. That's just for starters, Coffee. That was not the sole piece from which we picked the conclusion, this guy does not get it. He is not able to get it, or insert your qualifier here, not going to get it, can't get it, won't get it, not sure why you're not getting it, but we have our guesses. And I expressed mine.
So what did I state was the IV, DV, and CV that you felt was wrong, and what is the correct?
Oh, he's getting all pro with the acronyms. At the time, it was about separating the IVs being the distance from and the time, you know what I mean, that kind of thing. Or actually, the height, I guess the peak height would be the IV. The DV would be the time, of course.
So you believe the height is the IV?
Well, yeah, you pick your peak.
So that makes the height the IV? You're 100% correct about that?
It's an IV, yes. So is distance from the peak.
Have you
That is an IV.
Have you spoken to the constructor of this experiment?
Have I talked to Mike?
Yeah, to confirm this.
Oh, I'm pretty sure I would have heard an objection to that by now. It's been a month or something, hasn't it?
Oh, because I spoke to him a while back, and he told me that was incorrect.
He did. And what did he say?
Yes, he said that there's no exact predictive model. There's no model exact to call this a model-based experiment, right? Which led me to the conclusion that it's just comparative, right? You can only compare what the two models produced, right? And then use that to predict the outcome.
So he said there's no, you just said there's no model, and then you pick from two models. Which is it?
He said there's no model.
No experimental model.
Exactly.
But then you're picking from two models at the end based on the DV that comes back?
Yeah, you must have just misheard.
So again, you're not making sense, Coffee.
You must have just misheard me. Clearly. What did I just say, Stone? Let me see if you heard me correctly.
Well, I was just saying, yeah, that's exactly what you just said. You said there's no experimental model. That's what Mike told you. Is that correct?
Yes.
And then you use the same word to describe the consequent in an analysis of it, where the DV where it comes back by the time you're gonna put that against one model or the other model. You said that too.
Yeah. So you clearly
Which is it?
All right. So I'm gonna re-explain it so you can get it this time. I'm doing it a little slow.
Okay. What did Mike say? What did Mike say?
So he said specifically that his experiment doesn't adhere to any experimental model, meaning it doesn't adhere to what we understand as the standard of an independent variable, a controlled variable, and etc. Right? And all it leads to is us comparing our two personal models, the globe and the flat Earth, and its outcomes, right? Because without a predictive standard, right, there's nothing to confirm which model is correct. But he's clarified himself that there's no predictive qualities, right? And it doesn't adhere to any experimental standard.
Okay. So see, now I understand why you were using the same word for two things. You're talking about the difference between an experimental model and a physical model. Okay, so when it comes down to whether or not this satisfies all of the criteria and the requisites to an experiment, an experimental model, maybe he and I disagree. Maybe he hasn't thought of it on these terms. And what the fuck does that matter?
Just clarifies my point.
What point? What the fuck does that matter?
That your critique, right, over me not understanding these model variables, these experimental variables, right, it's just bullshit.
No, it is because you see,
it's not held with any substance, right?
It's not like you talked to Mike before we last spoke. You talked to him after. You see,
definitely spoke to him before
you're trying to take You're trying to pretend that your current level of knowledge is what you possessed last time we were talking. You see, that doesn't work. That's temporally illogical. Can you see that? That you can't assert that as any kind of like assessment to say,
I hear you,
oh, well,
Stone, but
since I talked about now I understand no, man, that's what the fuck are you talking about, Coffee?
I hear you upset, buddy, but that's just another assumption because I
Hold on a minute.
spoke
Hold on a
to.
minute. Hold on a minute. Hold on a minute. What
Go ahead,
exactly
Nick.
are we discussing here?
Yeah, no, we
Dude,
we could land it right after I say this. I don't want to take up the whole stage for this, right? It's not that
Are we
important.
just discussing how you guys are disagreeing on a certain
Variables,
topic?
IV and DV of cell Theo,
Hey,
I think was in
Stone.
contention.
so IV
Yeah.
DV's controls for Cell Theo. Known elevation of the mountain peak. We can't change that. That's our control. You can change your distance to the peak. That's an independent variable that you can manipulate. That variable will also be will also lead to a dependent variable of the angle, because the combination of your distance to the control is going to dictate the dependent variable for the occlusion. Now you wait for the occlusion to happen in nature, so like you don't have any control over that other than your distance to the peak. Now we're comparing the outcome for two different models, the globe versus a flat Earth. If the Earth is a globe, the physical mountain will be lower in elevation. It's going to have a different time for the occlusion. It's going to correspond to a different angle. So you can look at it in terms of experiment, like however you want to break it down like that, or you can like endlessly discuss a philosophical disagreement or whatever. Like that's of no importance. What is of importance is that we get two different outcomes that's possible, and the measurement leans towards one model in particular that shows the correct predictions for what you would make for doing rise over run to the peak versus rise over run minus globe drop to the peak. So
Oh, good
that's it.
call on the nomenclature right up front there, Alan. And if I recall correctly, you were actually the one to first mention the differentiation or the application of this nomenclature to begin with, IV and DV applying to the distance from the resultant angle, the peak, etc. And I would actually, sure, I would even agree the mountain is the control in that.
I'm so glad you agree because you came up with it.
Yeah, thanks, man.
I was like, yeah, you actually are the one that pointed that out the last time you and Coffee had
Yeah,
this conversation
yeah.
that went nowhere. So that's like super dope. That his takeaway from it was that there's somehow no mutual exclusivity and that we're comparing two models with no fucking metric. That
Yeah, well,
sounds like
that's his
so.
basis. Yeah, that's his basis. His misunderstanding is, oh, well, you can just pick whatever model you want, and it's like, no, that's nothing to do with no. There was an actual observation that either agrees with my model and disagrees with the other, or agrees with the other model and disagrees with mine. That's what mutual exclusivity means. So it's a very real observation that supports either one or the other. It's not
Yeah,
wishy-washy nonsense posting.
yeah, but his takeaway is that like you can just choose whichever one, and it's fine.
Yeah, I know, but
Hence,
that's
the
his
postulation of the
presupposition
null.
and his takeaway for some reason. He started with that and he ended with that. I don't understand.
Hey, Stone. I got the numbers for you here on tensile strength.
Oh,
Great,
God damn
post
it,
them.
bro.
I posted one. The spacecraft aluminum tensile strength.
Did you put that in the purple pill?
I can put it up there, yeah. The ultimate tensile strength, or UTS, is 42 KSI, which is kilopounds per square inch. So 42,000 pounds per square inch before it breaks.
Well, yeah. There you go. Nobody cares, I think, anyway, or whatever.
No, I
Right.
don't. I don't think it's whatever. I'd like to see the doc. It's what I asked you to post, not just you type it out all pretty. And I don't have a lot to go on here, man. Just your word. This is trust me, bro. Kind of quality information level. I'm sure you can understand that.
So, do you have any rebuttal for the information, or?
Okay, that's
What's your
only
source for that information is what he's asking.
that's only the quantification for T6, right?
Yeah, that's the aluminum that's mostly used on spacecraft.
Pounds per square inch. At what thickness? Nothing here. If you could post the doc, that might actually help. I don't know, man.
Tensile strength, thickness doesn't equate into that. That's the strength of the material itself.
The strength.
Yeah.
You understand how you're only giving me half a dimension?
That's how much force
Per
that
what?
material can withstand. Before it breaks.
So you've given me typed out spec for one type of aluminum and not the other ones we were talking about. So there's no quantitative comparison going here. And I asked for the doc.